we're going to look at rationalizing a denominator. We are not allowed to leave a radical in a denominator of a fraction. So if I have something like the square root of 2, the goal would be to turn that into its perfect square. Because if I can make it be into its perfect square, in this case 4, I know the square root of 4 just becomes 2. So to turn the square root of 2 into the square root of 4, that means I would want to multiply it by itself. So the square root of 2 times the square root of 2 would be the square root of 4, which would be 2. And to make sure I'm not changing my original fraction at all, I need to make sure that what I multiply here is equal to 1. So the square root of 2 over the square root of 2 is 1. So I'm not really changing the original value of my original problem. So now 10 times the square root of 2 would be 10 square roots of 2. And then finally, hopefully I would pick up on the fact that the 10 and 2 could be divided. So that would just leave us with 5 square roots of 2. Okay. In my second example, because this is a cube root, I would want to turn it into its perfect cube. So the perfect cube that goes with 3 is 27. And I know that the cube root of 27 would be 3. So for this one, I would not just want to multiply by the cube root of 3 here. I have to multiply by the cube root of 9, because the 3 times 9 would become 27, which would turn into the 3 here at the end. So I would multiply the top by the same thing, so cube root of 9 over the cube root of 9. So that's the cube root of 18. The final thing here would be to just make sure, when I think about the cube root of 18, I just want to make sure that there are no perfect cubes that would go into that. So obviously 8 does not, 27 would be too big. So we would then feel confident in saying that we have simplified all of the way. Okay, so hopefully watching that will help you if you are a little bit confused about rationalizing denominators.